So guys, in the last classes we have discussed about like we have a two in a single broadcast domain we have a DR and BDR concept. So basically what happened, OSPF has a two types of multicast address. One is a 224.0.0.5 and one is a 224.0.0.0.6, right? So 224.0.0.6 is going to represent as a DR and BDR, whereas 5 is going to represent the all OSPF router. Is it? Okay, and in the one broadcast domain, you will have a one DR and one BDR. And why we are going to select the DR and BDR in the one broadcast domain? To manage the domain, right? And every router, right? Every router is going to form the neighborship, right? Every router is form the neighborship with every router. But adjacency will form only DR and BDR. Is it? So all the DRO and I can't see your message, guys. Someone is in message. So sir, OSPF first से start किया है क्या? नहीं संकेत भाई, OSPF तो 2 दिन हो गए क्लास, 2-3 दिन हो गया. So I think so this is the third day of the class. So you just watch the video previous one. Okay, so OSPF what happened? OSPF is every router is going to form the neighborship with the every router, but the adjacency will form with the only DR and BDR. So basically what happened? Let me tell you. So DR and you have a DR, sorry, DR and BDR, you will have a form the neighborship and adjacency, right? DR is equal to DR, you are going to form the neighborship and adjacency. With the same thing, BDR with DR, you're going to form the neighborship and adjacency. But DRO and DRO only going to form the neighborship. That's it. They are not going to form the adjacency. Or adjacency means what? You are going to exchange the adjacency means what? You are going to exchange the route update. Adjacency means what? You are going to exchange the route update. Neighborship means what? You just have a neighborship. Neighborship means I just have a knowledge about that person. For example, R1, switch, R2, R3, R4, R5. By default, the priority of is equal to 0, 1, right? It's a 8-bit number you can define from 1 to 255. Sorry, 0 to 255. So by default, the priority 1, it will get tied, so it will become the high router ID will become the DR, right? So this guy has a high router ID, so this guy will be the DR and this guy is a BDR. And the election timer for this section is 40 seconds. That is known as a wait timer. And you cannot change the wait timer. If you're going to manipulate your hold on time, automatically wait time will be changed, right? For example, if your hold on time is 100 seconds, automatically wait will become the 100 seconds. Automatically. Is it? So what happened in this case? What R5 will become the DR and R4 will become the BDR because this is the higher router ID and this is the smaller router ID as compared to the 105. And this guy will become the DRO, DRO, and DRO. So in this case, what happened when R1 will receive any update, for example, 1.0.0/8, right? So what R1 is going to do? R1 will just flood this information to whom? This person. DRO, when the DRO will receive any information, they will first send this information to the DR and BDR. And what this guy will do now, once the DR will receive this information 1.0.0.0, now they will flood this information to the all person. And in a one broadcast domain, you will have a one DR and one BDR, and rest of the router will become the DRO. Priority is by default 1, priority get tied, so it will go for the high route ID. You can define the priority from 0 to 255. 0 is reserved. If you define any router, not router, if you define any interface as a priority 0, that interface will never participate in the DR and BDR election. If you define the any interface, right now, just take example, I have just say that, okay, you have a priority 0. At the same time, what happened? This guy is the priority 0. This guy will lose the, or we can just say that this guy will drop the DR condition and they will say that I'm the DRO now. So priority with the 0, right? They will never become the DR and BDR. Never ever. and only in the broadcast network and non-broadcast network you will have a DR and BDR concept. Point to point and point to multi-point. There's no DR BDR concept is happening. Only in the broadcast network and the non-broadcast network you will have a DR and BDR concept. Clear? और कुछ देखा था क्या? Anything else? No, that is the thing that we have discussed in the last session, right? Now let me do one thing. मेरे mouse काम कर रहा है. Response बहुत देर करता है मैंने. तेरा अपना calendar, तेरी अपनी agenda, मुझे नहीं. Right? 1201, 1202, this guy's route ID is 101. And this guy's route ID 102. Sorry, 202. Done? Now, so in this broadcast domain, right? In this broadcast domain, what happened? In this broadcast domain, what happened? This is a single broadcast domain right now happening. In this broadcast domain, what happened? One router, one interface will become the DR, and another interface will become the BDR. Now, do you know one thing? This is the one LAN network that's behind the R1, and this is the another LAN network that's behind the R2. Before exchanging the route information, when R1 is going to share this information to the R2, and when R2 is going to share the own information to the R1, whatever the LAN network information, and this is the LAN network information, and this is another LAN network information, right? Whenever R1 is going to share this information, own LAN network information to the R2, and whenever R2 is going to share the own LAN network information to the R1, before exchanging this information, what happened? A router has to go through the some states. Router has gone through the some state, and that state is known as a OSPF states. It is something like that. Do you know one thing? There is a building over there. In this building over there, we have a first floor, we have a second floor, we have a third floor, we have a fourth floor, and we have a fifth floor. On the fifth floor, what happened? The person are sitting over there, right? This person are sitting. Okay. Okay. And this fifth floor is going to kind of the rooftop is there. Just take example, one restaurant is there on the fifth floor, right? This is the fifth floor, and one restaurant is there. And there is a guy that is sitting over there. And this guy wants to go. This guy name is ABC, and this guy wants to meet this person XYZ. This guy wants to meet this person. What they will do? They don't have any lift. They don't have any lift. So what happened when if this person ABC wants to meet the XYZ, if this person ABC wants to meet XYZ, they has to go through the first floor, then second floor, then third floor, then fourth floor, and then fifth floor. Step by step, we have to go to the fifth floor because they don't have a lift over there. Same thing happening with the OSPF. When OSPF is going to share the own line information to the R2, and when R2 is going to share the own line information to the R1, before exchanging the update, right? In a simple, before exchanging update, what OSPF router is going to do? It has to go through the some state, and that state is known as a OSPF states before exchanging the information. So whatever the OSPF states we have, the first state of the OSPF is a down state. Second is init. Third is to be. Fourth is extract. Fifth is exchange, loading. Sorry. So basically what happened when before the exchanging the router information, OSPF before the OSPF router is going to exchange the LAN information, they have to go through this router, right? This guy has to go through the down init attempt to wait, start exchange and loading info. So once I'm going to enable the OSPF, once as I told you that yesterday, there's one guy that's sitting in the one airport location. So this is the Dubai airport location, and in Dubai, what happened? This is the Vinay, and this is the Anup, right? And so Dubai airport. So what happened? Anup has some magazines, right? They have some magazines over there. So they don't know each other. Vinay is belong from the USA, and Anup has belonged from the UK. They don't know each other. If the Vinay wants to see this magazine, what they have to do? They first need to form the neighborship, right? Hey, I am Vinay. Is it right? Hey, I'm Vinay. If the Anup is interested, right? If the Anup is interested, then what Anup is going to do? He's going to say that, hey, I'm Anup. This information. So what happened? So Binay will know that okay, this is Anup, and Anup has a idea. This is the Binay. This is known as a neighborship, right? A person has a knowledge about the person. But before forming the neighborship, right? Before forming the neighborship with the Binay and Anup, what this guy will do? They will check the criteria, right? They will check the criteria in the sense of you cannot form whenever you are receiving some friend request, whenever you're sending the friend request in your Facebook. What happened? You first check, is this person is belongs to my any mutual friend? Whenever you're sending a friend request on a Facebook, what happened? You just check it, right? Is this person is belongs to the my mutual friend or not? Do I know this person? You are just finding some common thing, right? You are just finding the some common thing. When you're making a neighbor relationship, with some person, you're just finding the common things. If you're finding the common thing, if everything is perfect, then you can form the neighborship. Is it? If everything is perfect, then you can form the neighborship. Like in the EIGRP case, what happened? ACE number should be same, right? Then subnet should be same, key values should be same, authentication should be same, and timer should be same. These are the things. If these things should be same on R1 and R2, then you can form the neighborship. The common thing, right? Same thing when the Binay is going to form the neighborship with the Anup, what happened? They will check the criteria. Do we have some common thing over there? If we have a common thing, then I can form the neighborship. Right now I'm only talking about the neighborship. In the neighborship, what happened? A person has knowledge about the different person. A person has a knowledge about the different, but that has a knowledge only. So whatever the neighborship criteria of the OSPF, if I'm going to talk about the neighborship criteria, the OSPF neighborship criteria, the first it will check it should belong to the same subnet, mask, must have different router ID, same timer, then stub flag should be same. By default, it is 1. NSS flag. Don't ask me a question about this one right now. I'm not going to explain you this in NSS and stuff. By default, it is One means they have a ability to receive the external. We'll talk about this thing later on. Forget this one, but remember this thing, it should be seen, right? Then after that, authentication should be seen. Anything else? Seen subnet mask, seen router ID, seen area should be seen. These are the neighborship criteria. It means that when the R1, right, when the R1 is going to form the neighborship with the R2, when the R1 is going to form the neighborship with the R2, first of all, they belong to the same subnet right now. This is good, right? Because they have a same subnet 12.0/24, right? They have a same subnet mask. Is it? So the first two line is same. Then they have a must have a different route ID. So of course this guy has a different route ID 101, and this guy has a different route ID 2.2.2.2. Then they have a same timer in the sense of what? This should be a hello timer will be a 5 second, sorry 10 second, and hold on to it should be a 40 second. This should be same on our both side. If it is different, they cannot form the neighborship. If it is different, they will not form the, for example, if I say the 50 over there, they will never form the neighborship. It should be same, right? Router ID should be different in the OSPF case, but in the EIGRP case, it's not recommendation. In the EIGRP case, what happened if the router ID is same, they can form the neighborship. Stuff like NSS, forget this thing right now. Authentication should be same. If authentication is password over there, Sunil, just give me some time. I'll explain you MTU as well as okay. So authentication should be same. This is the optional thing, right? If you have authentication, then it should be same. Otherwise, no need to have this one as well as. It is optional. Then area should be same. Area should be same in the sense of what? This interface is belong from area 0. Then also this interface belong from the area 0. If everything is same, right, then the router is going to form the neighborship. Then the router is going to exchange the packet. Clear? So all this information will be sent in the hello packet. The first OSPF packet is the hello packet. This packet is used to form the neighborship, okay, and maintain the neighborship. By default, it's sent every 10 seconds. In this case, what happened? The source will be a source IP will be a interface IP, whereas destination IP will be a multicast. So once I'm going to enable the OSPF, right? Once I'm going to enable the OSPF on this interface, at the same time, what happened? The router 1 is going to, this interface is going to send the first hello packet. Once I'm going to enable the, once I'm going to put the command router OSPF number 1, as a network 192.12.0/24 and area 0. Once I'm going to put this command, what happened? The router 1, right? The router 1 from this interface, it will send the hello packet. And in this hello packet, you will have all this information. This hello packet will be encapsulated with the with IP header, with protocol number 89. And the TTL value set will be to this guy 1. So once the router, for example, this is the router is going to send the hello packet. So I'm going to encapsulate this hello packet with the IP header. This is my IP header. And this IP address, we have a source IP address. For example, if R1 is sending, the source IP address is 12.1. Destination IP will be a multicast. We have a IP protocol number 89, and the TTL will be. So this encapsulation is what I'm going to cover something, right? This is the phone, right? Just take example. This is the phone that I have purchased. This is the phone that I have purchased. I need to courier this phone, right? I need to courier this phone. So what we have to do? We need to cover this phone with this something, right? This is the box that I'm going to cover. This is the meaning of encapsulation. So the hello packet is now encapsulated with the IP header. So once I put this command router OSPF 1 on the router number 1, at the same time, what happened? The router has moved in the down state. Because in this case, what happened? Because in this case, what happened? Now the R1 is sending the packet to the R2, right? Now R1 is sending the hello packet to the R2. This is the hello packet that I'm sending to the R2. But I'm not able to receive any hello packet from the neighbor. This is the down state. Can I read this line? Let me do one thing. Well, as I told you that once I put this command right on a router number OSPF 1, right, router number 1. So what happened? Router 1 is going to send the hello packet. Router 1 is going to send the hello packet from this interface to L.1, right? What happened in this case? Will I able to receive any hello packet? And this hello packet will be a multicast, and this is the periodic hello packet. This is the periodic hello. At every 10 seconds, I'm going to send this hello packet. At every 10 seconds. At every 10 seconds, what happened? I'm going to send the hello packet. This hello packet is the periodic packet that will be sent at every 10 seconds. So once I send the hello packet, try to read this line. This is the first OSPF neighbor state, right? As a down state, the first OSPF neighbor state. Okay, this is the first state of the OSPF. It means that no information hello has been received from this neighbor. So this is the R1. I'm not able to receive any hello packet from the neighbor, right? I'm only sending, but I'm only able to send this hello packet to the R2. Clear? What happened if I'm going to configure the same command? Let me do one thing. Copy. Yes. If I'm going to put the same command on R2, what happened? Now R2 is going to send the another hello packet. And again, this hello packet is a multicast. This hello packet is a multicast. So again, now in this case, what happened? The source IP address will be 12.2 and destination IP address will be 224.0.0.5. Now the source, the packet will look like this. Source IP address will be 12.2, destination will be After the election, right? After the election, they will join the 224.0.06. Once the DR and BDR has been elected, then they will join the 224.0.06. But at the first time, they first join the 224.0.05. Now R2 has sent the hello packet. So what happened? R1 has sent the own hello packet, and R2 has sent the own hello packet to the R1. Now both this router will receive the exchange the hello packet. Once the both router is going to exchange the packet, what happened? Now they will move in the. I'll explain in the attempt state. Forget this thing right now. Then it will skip the attempt because this attempt state is only going to use in the NBA environment. And in this state, what happened in the attempt is all this hello packet will be unicast. Because in this case, what happened? I'm going to manually configure the neighbor statement. This is the dynamic behavior, guys. This is the dynamic behavior that I'm using right now. This is a dynamic behavior to form the neighborship. This is the dynamic behavior. Once you put the neighbor statement, remember the BGP, the neighbor statement you are giving, right? That is a static neighborship. This is the dynamic neighborship. So this attempt only comes in the NBA environment. In that case, what happened? The router will send the unicast hello packet. So that this is not used because this is an NVMe environment that is used in the frame relay concept, right? So this is a totally legacy technology right now. We are not using this thing.
Excuse me, sir.
Yes.
Sir, till now, DR and BDR selection will not have happened.
आता हूँ Anup, 1 minute. I'm just come to that point as well. 1 minute. Till now, no DR BDR has selected.
Okay, because you told multicast address, sir.
So what happened? Did I put the 224.06 over there? 5 is there, right? So what happened when the router 1 is going to send the own hello packet and the router 2 is going to send the own hello packet. Both this router is going to exchange the hello packet right now. Both this router is going to exchange the hello packet. If the criteria will matches, right? Now what happened? It will move in the init state. In the init state, what happened? The state is specified. Let me explain again this one. Try to send this state is going to say that router has received the hello packet. As I told you that, so router 1 has sent the hello packet to the R2 and R2 is going to send the own hello packet to the R1. So in both cases, what happened? Now the router has exchanged the hello packet. Router has received the hello packet. As per the perspective of R1, router has received the hello packet from the neighbor, right? But in this hello packet, what happened? I don't have any router ID. And that's why what happened? It is known as a unidirectional. Unidirectional means what? R1 has sent the own hello packet to the R2 and R2 has sent the own hello packet to the R1. If you have a look over there, let me show you the Wireshark. I can do one thing. Interface 0/0 IP address /24 /8. Interface number 1/8. Right. Let's do one thing. Debug IP OSPF events, not events. Flood, not flood. Debug OSPF. Debug IP OSPF. What the command was there, man? adjacency, right? And I can enable the hello, I'm not interested packet, I'm not interested. Adjacency is fine, you can see that information, debug IP also adjacency. So right now nothing has to enable, right? Let's go on R1 and R2 as well as interface 0/0 IP OSPF 1 area 0. I'm not going to put the enter over there. Interface 0/0 IP OSPF 1 area 0, right? So now both are auto. I have given the command. I'm not going to put enter right now. Let's do one thing. Let's put the enter. Let's put the enter. And just wait for some time. OSPF is a little bit slow routing protocol. You have to just wait for the patience because the data interval is 40 seconds and wait time is a 40 seconds. That is the election of DR and VDR. So if you see over there, do show IP OSPF interface 0/0. What happened? The street is waiting, right? And how many seconds still? 14 seconds. Just wait for the 14 second more. Okay, chalo. So if you see the first hello packet I have sent from the 12.1, right? R1 has sent the first hello packet. If you open this guy, you will have a source MAC address of this person, the R1, this one, right? Do show interface 0/0 include a. This is the MAC address of this person. Is it? And the destination is a multicast MAC address for the OSPF 01005B. This is the 23 bit is reserved. Actually 20 bit is 24, but 23 bit is reserved for the multicast, right? And the 24 is reserved, and then you have a 00005. This is the reserved multicast address for the OSPF dot 5. Then 12.1 is the source IP address that R1 is sending this packet. Right? Source will be an interface 0/12.1 and destination will be 224.0.0.5. If you just open this packet, so if you see the TTL is one that I told you that, and the protocol is going to use the OSPF IGP89. IGP means what? It's a interior gateway routing protocol. Source, destination. Clear? This is the encapsulation. Can you see that this is the first is the IP header is coming. First is IP is coming, then you have a OSPF. So OSPF, all the packet of the OSPF will encapsulate with the IP. So that's why I told you that if you see this diagram, same thing is happening. This is the OSPF, this is the IP header. Then after that we have a hello packet. The first is the IP header. So, clear? The first is the IP header, the source 12 around distance, and if you open the OPS part first, OSPF header is there. In this OSPF header, what I told you that OSPF has a start with the version 0 and version 1. That was totally experimental purpose. We are currently using the version 2 for the IPv4. The message type is hello packet, and this is the opcode value, right? So I don't need to explain the what is meaning of opcode. We already discussed this thing, right? So this message type can be changed. It can be a hello, it can be a DVD, it can be a LSR, it can be a LSU, and it can be a LS acknowledge. So depend on the masses, right? Depend on the packet type. This field will be changed over there. It can be a hello, it can be a DVD, it can be a LSR, it can be a LSU, and it can be a LSA acknowledge. Then after that, we have a size of this packet. The size of this packet is a 44 bytes. The source OSPF router is 101 because R1 is sending this packet. If you see R1, go on R1 and show IP OSPF include ID. Area ID is 0.0.0, that's a backbone area, as I told you that, and it's a representation in the IP address format, that is a 32-bit number, right? Checksum, that is going to check the is there any error in this packet or not, and this checksum is only for the OSPF header, not for the IP header. This checksum is only for the OSPF header, not for the IP header. So checksum is good, right? Then after that we have a authentication type. Authentication type, it can be a, by default it is a null, so we have a null authentication, then we have a text authentication, and then we have a MD5 authentication. If you have a null, the opcode will be 0. If you have a text, the opcode will be 1. And if you have an MD5, the opcode will be 2. This opcode value will be changed. So right now authentication type is null. So what happened? Of course, we don't have any authentication data. This is the OSPF header of the version 2 for the IPv4. Then after that, if you see the hello packet, still I'm present in the init state right now. After that, if you see the OSPF hello packet, in this OSPF hello packet, what happened? You will have a lots of information. Can you see that network mask, the hello interval, then option field? This is going to tell you that that I told you the NSSA, and then stop flag. This is the NSSA flag. This is the stop flag. This one, this field, these two field. So we'll discuss this thing later on. This is the 8-bit number, right? This is the 8-bit field. So we'll discuss this thing later on, not now. So otherwise you will get confused over there. Okay. So I'm just going to remove the option field. This is the 8-bit over there. And then if you check the router priority, that is the by default priority of this interface, right? So when R1 is sending this packet, do show IP OSPF interface brief, right? Do show IP OSPF interface 0/0, the priority one of this interface 0/0 that has IP address 12 or 1. So if you see this guy priority is 1, dead interval is 40 seconds. And what he's saying at the DR and BDR. This is the most important interview question. They will ask you what is the meaning of DR 0.0.0 and what is the meaning of BDR 0.0.0. The meaning of DR and BDR, what happened? He's going to say that no DR and BDR has been elected. The DR and BDR of the 0.0, if you have a next hop 0.0.0, right? Try to understand this thing, guys. If you have a next hop 0.0, it means that these are my directly connected router. These are my directly connected router. If you have a DR and BDR 0.0, it means that no DR and BDR has been elected yet. Clear? So this is the first OSPF hello packet, right? This is the first OSPF hello packet that I have matched this guy. Let me mark this portion. Then R2, this is the first hello packet that R1 is sending. They will move in the down state. Then R2 has sent the hello packet. Same information will be there. If you see, the thing is that OSPF source router will be changed over there. If you just compare with this capture to this capture, now you can see that R1 is sending this packet, R2 is sending this packet. Same area, same subnet mask, same subnet mask, hello interval same, dead interval same, dead interval same, DR no, not elected. Both the router has exchanged the hello packet. If both the router exchange the hello packet, what happened? Now they will move in the init state. In the init state, what happened? The router has received, right, hello packet from its neighbor, but the receiving router ID is not included, is it, in the hello packet? So there is no router ID. This is the OSPF router ID. This is the OSPF router ID. This is the source OSPF router ID. This is the source OSPF router ID. This is the source OSPF router ID. I don't have a in this route in this packet. What happened? This is the source router ID of 2.2. When the R2 will send this packet, right? Of course, they will have a source router ID. At the same time, what happened? When router is going to send the hello packet, next hello packet, it will contain the 1.1.1, the router ID of neighbor. then it will move in the two-way state. So right now there is no two-way state is happening. This is the source OSPF router ID, and when the router is going to send the next hello packet to the R1, in that hello packet they will contain the neighbor router ID. That's why he's saying that this line is try to understand this line. But receiving router ID was not included. Do we have any router ID included of the neighbor? No. So this is not a two-way state. This is the init state. In the init state, what happened? Both the router is going to exchange the hello packet. That's it. Both the router is going to exchange.
Sir, in the next hello packet, they
1 मिनट,
are
एक मिनट भाई, एक मिनट में आया उस पे भी आता हूँ. So in this case, what happened? The router 1 is going to send the own hello packet that has a router ID 101, source router ID, right? And this guy is in the own hello packet, this router ID. So this is the init state, right? We can say that this is the unidirectional state. Unidirectional means what? R1 has sent the own hello packet to the R2, and R2 has sent the own hello packet to the R1. That's it. In the next hello packet, what happened? Now, in the next hello packet, what happened now? R1 is going to send the hello packet. Again, the source router ID will be 101. Source router ID 2.2.2. This is the source router ID 2.2.2. But in this case, what happened? We have an active neighbor, right? And he's going to say that active neighbor. Active neighbor means what? Now R2 has an information about R1. Now R2 has an information about R1. R1 has an information about R2. So now this both the router, right? Now the both the router has an idea. R1 has an idea about R2, and R2 has an idea about R1. This is known as a bidirectional state. This bidirectional state is known as a two-way state. Why I'm saying a bidirectional and why I'm saying a two-way state? Because bidirectional means what? Both the person has a knowledge. R1 has a knowledge about R2, and R2 has a knowledge about R1. That's the meaning of bidirectional, two-way. We can drive my car from this way and this way as well as. And in this state, what happened? In this two-way state, your DR and BDR will be erected. Two-way state, right? Bidirectional communication, right, has been established between the two routers. Bidirectional means what? Each router has seen the hello packet. As I know that if you see, each router has seen the hello packet, right? That's why R1 is going to put the information on R2, and R2 is going to put the information on R1. R2 has an idea that someone is present, right? R2 has an idea that someone is present, and R1 has an idea that someone is present. That's the meaning of bidirectional. Both the person has a knowledge, right? This state is attained to when the router is receiving the hello packet and sees the own router ID. Same thing is happening, right? So router 1 is sending the hello packet to the R2, this hello packet. So when the router 2 will receive this hello packet on this interface 0/0, What they will do? They will look up, oh, I have my own route ID over there. That's the same here. Route this state is going to entertain the when the router receive the hello packet and see the own route ID. At the same time, what happened? And this state, what happened? At this state, router decide whether to become the adjacent, it meaning the adjacency, or whether to become the neighbor. As I told you that every router is not going to form the neighborship and adjacency, right? With every router, only only the DRO is going to form the neighborship and adjacency with the DR. Only DR is going to form the neighborship and adjacency with the DRO and BDR as well as. So this state is going to also elect that who will be who will become the DR and BDR at the same time. At the same time, is going to decide, should I become the adjacency? If I'm going to become the adjacency, then I have to move in the next state. If I would become the neighbor, then I will stuck in the two-way state. If the router is going to form the neighbor, then it will only stuck in the two-way state. And if the router is going to form the adjacency, then it will move in the next state. And in this case, what happened in this state, the router become the fully only the adjacent, and DR and backup DR has been elected. On a point-to-point network and a point-to-multipoint network, there is no DR and BDR concept. A router will become the full with the all connected router, but there is no DR and BDR because the DR and BDR concept is not happening on the point-to-point and point-to-multipoint network. So as I told you that the DR and BDR only elected in the broadcast and non-broadcast multi-access network. So if you see now, still I am present on the this one two-way state. Let's go to the two-way packet. So this two packet has cleared. In this two packet, what happened? There's no any router ID, the neighbor router ID. Let's go for the next packet. This one. Let me open the next one. This one also done. Mark. And now this one. So you see that the two-way state is going to represent that both the router is going to exchange the packet, and now they have information over the neighbor router ID. So now if you see that R1 is sending this packet to the R2, and in this case what happened? They are putting the active neighbor 2.2.2. That is the meaning of two-way state. R2 is going to send the packet, and they are going to put the they have moved in the two-way state now. Now you can ask me the question. So someone asked the question. Who was it? Ankur. Now you can ask the question.
Also, it's clear. ये पूछना था वो next packet वाला two way वाली.
Clear again?
हाँ yes sir.
So till this point, do we have any doubt or DR and BDR guys? No. Two-way state में आ गया. This packet has the router has moved in the two-way state, but still there's no DR and BDR because in the two-way state the DR and BDR is elected. They have moved in the two-way state, right? This guy has moved in the this box that his name is two-way, but still, if I have to go through this box, then what happened? I need to wait for some second. That is the waiting timer. So if you see how many seconds that I have spent, if you go through that, 78, 10 seconds, 88, right? 10 seconds has over. Go to the next hello packet. No dear video. Why? Still right. 78. Then you have to look at the 12.1 IP address. 88. 10 second. 10 second. 30 second. Is it? Next one. 40. And now this is the next packet. The 40 and this one is the next. No, this one is the next packet. 78 to 40. How much it? कितना होता है? 118, 108. So now if you see the next packet, if not this one, if you there's the next one packet, next this is the 12 one this packet. मिल गया? High route ID 1202. This is the high route ID, of course. तो ये बनेगा DR और ये बनेगा BDR. कौन भेज रहा है पैकेट? OSPF is R1 is sending this packet and he's saying that router DR is 1202 and BDR is 1202. अरे ऐसा नहीं है यार, ये नहीं होगा. BDR is a 1201 होगा. Some next packet you see. It's not like that. Yeah, it's clear now. Just give me 1 minute. I'll just come back. Right. So as I told you that if the in this state what happened, the router is going to decide should I go for the adjacency or neighbor. If I'm going to form the neighborship, then I'm only going to move in the two-way state. I will stuck in the two-way state. If I'm from the adjacency, then what happened, as we know that DR and BDR can form the neighborship at the same time adjacency, right? So now it will move in the next state because they have the ability to form the adjacency. And the next state is extract. Chale? Now let's come to the example again. So till now, how many packets we have discussed? I have just discussed the hello packet. Next packet is DVD packet. DVD stands for database descriptor. This packet information about MTU and master and slave. This packet also hold the information about LSC header. We can see that summary information. Some issue with the mouth. Now try to understand. I'll make it more easy. What I can do over there to understand the OSPF states and the DVD. Now understand from here. This is the guy, right? This is another guy. Okay. And this is the one girl over there. Yeah, I can't see you the message. You can speak out, right? Because I don't know what happened with this. Sometimes Zoom my problem is creating, right? You can speak out.
So in the election process, BDR will be selected. So then the DR will be selected, right?
Right,
So
right, right.
so in the message, I saw the 12.2 was showing as a DR and BDR. So it will
That
be
was the
the
error. That was error. It's not look like this. It's all error. It is not look like this. It should be DR and VDR. The first packet I showed you, right? That was error. It should be
there
DR
was
and
error. Oh,
yeah.
because I thought both will be elected at the same,
No,
then
no,
it will
no,
be
no, no, no.
transition into the DR.
But election first happened with the BDR because to become the DR, right? To become the DR, what is the criteria? To become the DR, you first need to go through the BDR concept. Like that, if you want to become the prime minister, right? What you have to do? First, you become the CM, then you have to reach to the PM counter. Same thing. If you want to become the DR, you first need to become the BDR, and then you have to go to the DR concept.
So then, what was the state of 12.2 before become the DR? Was it as a BDR earlier in the
No, no,
real-time
no.
event?
So repeat again.
No, no. As you mentioned that you must be a BDR before you become as a DR. So,
Mm-hmm.
and in this scenario,
Mm-hmm.
so 12.2 was selected as a BDR in the real-time event before it was
Yeah,
transitioned into the DR. That is my
exactly.
doubt.
Right, 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 right,
So
right.
that's why in the event it was. I thought it was a right one or it's a mistake
No, no, no.
as per
It's 1 minute. Where is that? This packet. But in this one, what happened? It will show like it will both. It will give that information like this guy, right? This information should be look like this. It should be 12.1 over there, not 12.2 will happen over there.
but after 12.1 become a DR, so then it can be a 12.2 or
Yeah,
12.1, right?
that's why it's in it should be a backup DR, right? But it is
Yeah,
saying that
yeah.
it should be a DR as well as. I'll
Okay.
show you in the debug message. Don't worry. I'll show
Sure,
you in the.
sure, sure. Okay, okay.
Now try to understand this guy. What happened? This is the guy name is, for example, this is the Amit, right? And this is the Ambush, okay? And there's a girl over there. That name is Keel naam yaar iska. Shruti, right? So this girl has a phone number is 123. This is the phone number, right? This guy has a phone number 456, and this guy has a phone number is 768, right? What happened in this case? Try to understand. Amit has a number, right, in the phone book. In the phone book, what happened? Amit has a number about like Ambush. In the phone book of Ambush, right? They have a number of Amit, and then they have a number of Shruti, right? Is it? Now try to understand what happened. First of all, these two guys, right? These two guys are very close friend, right? These two guys are very close friend, and they met after the 10 years. These are the two close friends, and they met after the 10 years. In this case, what happened? Try to understand. These two guys are close friends. They met after 2 years in the Bangalore airport. So what happened? Ambuj is saying that I want to share some information with you, and Amit is going to say that I want to share some information with you. So they are right now fighting to each other. They are right now fighting to each other to share the information because of course they are meeting after the 10 years, so they are fighting to each other that I have some information for you, and he's saying that I have some information for you. They are fighting to each other. So in this case, what happened? I need to make an election. I need to make an election. Okay, I said that do one thing. Do one thing. You share the first information because you are big, because you are the manager. You can say the first one, then I can say the. So Ambuj will say the first information, and then Amit is going to say the information. Once Ambuj has been completed, right? Once Ambuj has been completed, now Amit is going to share the information. Okay, but at the same time, what happened? They cannot share each information at the same time. He cannot say the this information, and this guy say the this information at the same time. It's not possible. Same thing happened with the router. In this case, what happened? Router has some LAN network over there. and this guy has R2 has also landed over there. So once the bidirectional state has completed, right? Once this state has completed, the bidirectional state, and we can say the two-way state. Now what happened? The router will move in the X-start state. In the X-start state, what happened? First of all, as I told you that in the two-way state, your neighborship has been completed, right? Now they are moving adjacency state. This was my neighborship criteria, right? These are my neighborship criteria. Do we have any criteria for the adjacency state? Of course, we have one criteria for the only one criteria we have adjacency state. MTU should be C. Only single criteria we have. MTU should be C. Before exchanging the information, because in the two-way state, what happened? Your neighbor state has completed. Now they are moving in the adjacency state, right? And to form the adjacency, right? Once they will come to the X-start state. In the X-start state, what happened? Both the router. Once this guy has moved to the X-start state, now both the router is going to check the MTU value by default. By default, the MTU is set to the 1500 and 1500, right? If MTU is same, right? And in the DVD packet, right? In the DVD packet, you will have a MTU information. In the DVD packet, you will have a MTU information, and that is just going to determine should I form the adjacency or not. If the MTU will same, then I can form the adjacency. So let's see the DVD packet now. Same, the header is same, nothing is difference. Only the message has changed with the DB description, and the opcode value is 2. The hello was 1. Now if you see, we have a MTU field over there. If you see, this is the packet by the R1. If you go for the R2 now, both this guy has a same MTU. If the MTU will be same, right? If the MTU will be same, now it's come to the election criteria for the master and slave. As I told you that, if you see this again diagram, in this diagram, what happened? The Ambuj and Amit was there. They are meeting to each other in the Bangalore airport. In the Bangalore airport, what happened? They are meeting after the 10 years, right? So this guy is going to say that I want to say the information. This guy is saying I want to say the information. So they are fighting to each other. Same thing happened with your this router. Once the router has moved in the X-start state, right? They send the DVD packet. They send the DVD packet to this guy, and R2 has sent the own DVD packet to the R1. Both the router has sent the DVD packet. Both the router has sent the DVD packet. If the MTU will be same, by default the MTU is 1500 over there. If the MTU will be same, then what happened? Now R1 is saying that I want to say the first information, and R2 is saying that I want to say the first. They are right now both are fighting. I want to say the first information. I want to say the first information. So what happened in this case? I need to find the master and slave election. The master and slave election is totally different from the DR and BDR. what master and slave is going to, what is the meaning of master? If you just have a look on the master key, what is the meaning of master over there? Master means what? I am the owner, right? I am the king. Master means what? I am the owner, I am the king, I can share the information with you. Slave means what? Slave is just going to receive response the information, right? Once the master has completed, then slave is going to say, once the master has exchanged the information, once the master has said the information, then slave is going to say the information to the master. But first master is going to make Alex say the information. So in this case, what happened, once the DVD packet I say, in the DVD packet what happened, I'm going to say the M2 field, the M2 is for ID for is 1500 over there, and this guy is also 1500. If the M2 will be same, then what happened, I'm going to make a master and slave election. And this is the initial DVD packet. This initial means what? This is the first DVD packet that we are just is going to represent that we are moving in the adjacency state. This is the initial DVD packet. So if you see this one, the first two DVD packet over there, the R1 and R2. At the board, at the starting time, what happened? As I told you, this has an empty field over there. Sorry. If you see that both has the same empty over there, then what happened at the same time? R2 is saying that and R1 is saying that both are saying that I am the master. Or this one. This one. Both the router is going to say that I am the master. MS field. Master, MS means what? MS means master and slave, right? MS is going to represent that it's a master and slave. Right? So right now what happened? R1 is saying that I am the master because the one is on. One means on means what? It's I'm the man. One is going to represent a master and zero is going to represent a slave. So R1 is saying that I'm the master and R2 is also saying that I'm the master. And this is my first DVD packet. How we can get to know that? Because this is the init bit is set. Init bit is what? It is the first DVD packet. Mode bit means what? The mode bit is going to represent that I have a more DVD packets. I have a more DVD packet. What is the sequence number of R2? What is the sequence number of R1? This sequence number is just going to tell you, this sequence number is just going to represent that order of the packets so that the duplication will not happen. So right now both the router is saying that I'm the master and I'm the master, right? But in this case, what happened? Those router has a higher router ID will become the master. If you have a look in the next packet, I'm not a master because I have a lower router ID. I'm not a master, I have a lower router ID. If you go to R2 now, I'm master. Again, the init bit has completed, right? It's a 0 means what I have done with the init state, right? Now it will move in the more bit means what I have a more DBD packets. More means what I have a more DBD packet. Master right now is the master. R1 is saying I'm not a master. If you go for this one, I'm not a master. MS bit is going to represent as the master and slave. MS is 1 is equal to master, MS 0 is equal to slave information. And which state is happening this thing? The master and slave election, right? It has happened in the start state. Once the DR and BDR will be elected in the two-way state, once the DR and BDR will be elected in the two-way state, now they will move in the actual process of accessing the link state information. And what is the meaning of link state information? That is the meaning of LSA, information about link. Information about link. And how we can access the link information in the adjacency state. So in this extra state, what happened? The router that the DR media established has completed. Now they will go for the master and slave relationship. The router with the higher router ID become the master and start exchange the information. And only the master router can increment, right? Sequence number. And what is the use of sequence number? To check the order of the packet. Is there any duplication or not? In the extra state, once the master and slave has completed. And one more thing that I want to share with you. For example, this is the most important interview question, guys. R2, right? So this guy's a 12.1 and this guy's a 12.2. In this case, what happened? For example, if this guy's a priority is 255 and this guy's a priority is 1 by default. So this guy will become the DR and this guy will become the BDR. Is it? This guy's a route ID 101, this guy's a route ID 202. So in this case, what happened? Who will become the master and slave? This guy will become the slave and this guy will become the master. So it's not like that. What they will ask you the question, is this a good scenario or a bad scenario, right? Will the slave will become the DR? Will the slave router will become the DR or not? Yes, they will become it. Clear? Now have a look over there. Now what happened? As this point, let's come to this point. Now both the Ambuj and Amit has decided to exchange the information. The Ambuj is the first. He's going to say, I'm going to exchange the first information, right? Because I'm the owner. So this guy's a master in a simple language, and this guy's a slave. So what master is going to inform to the slave, Ambuj is informing to the Amit. Ambuj is sending the message to the Amit. Hey Amit, I have a number of 50. Try to understand. Ambuj is sending a message. Ambuj is sending a message. I have a number of Amit. Sorry, Shruti. In this database, right? If you Ambuj check the Ambuj database, they have a Shruti number, right? And they have Amit number. So Ambuj is informing to the Amit, hey, Amit, I have a number of Shruti. What Amit is going to tell this person? So if you see, I'm just sending the short information. This is the short information, not a complete information, guys. This is the short information, not a complete information. The packet is going to contain the DVD packet. This packet hold the information about the LSA header. That is summary information, brief information, short information, but not of the detailed information. Am I sending the number of Shruti in this packet? Am I sending the number of Shruti of this packet? No. I'm just informing to the Amit, hey Amit, I have a number of Shruti. You want it? So at the same time, what happened? Router 1 is going to send the own router LSA and router 2 is going to send the own LSA. Router 1 is going to send the own LSA and router 2 is going to send the own LSA. If you have a look over there, router 1 is going to send the own LSA. In the first DVD packet, if you have a look, in that one, there is no LSA information there. No LSA information. But in this case, what happened? We have a LSA information. We have a LSA information. So in the initial packet, what happened? We don't have a LSA information. The next packet will have a LSA information. If you click on this packet, and if you have a look over there, I'm not sending a detailed information. I'm just informing the router number 2. Hey, router number 2, I have some LSA for you. And router number 2 is also going to send this information to the R1. I have something for you. So both the router is going to exchange the LSA information. But this is just a short information, not a detailed information. This is just a short information. And this exchanging has done in the exchange state because I'm exchanging my LSA information. In the exchange state, what happened? Now both are router exchange own summary information, or we can say that LSA header information, but not detailed information. Have the Ambuj is sending the detailed information there? No, Ambuj is just informing to the Amit, hey Amit, I have a number of Shruti. I have a number of Shruti, but I'm not sending a number of Shruti. Try to understand this thing. I'm not sending a number of Shruti. I'm just asking, I have a number of Shruti. So same thing is happening. If you have a look over there in the exchange state, what happened? And that DVD packet is going to contain the link state advertisement, LSA information. That is only a LSA header information, only a LSA header, not a describe information. They don't have a detailed information over there. So in this session, what happened? For example, our Ambuj has informed to the Amit, hey Amit, I have a number of this one. So what Amit is going to inform to the Ambuj, hey, give me the number. Hey, give me the number. So this packet was DVD packet. This packet is LSR packet, link state request. whatever the information that you have sent in the DVD packet, what Amit is going to do, Amit is requesting the same information by using the request packet, link state request packet. If you go in this one, so see R1 and R2 both have sending the link state packet, right? Just click on any one router. So if you see just packet, this is just a request packet, link state request. The message have changed with the 3 upload. And I'm just informing, hey, whatever the information that you give me, if you see this one, not this one, this one, no, this one, yeah. So if you see, R2 source route ID, right? R2 had sent the information to the R1 about the LSA1. What R1 is doing, R1 is giving the request, hey, give me the information about the 2.2 because you have sent the this information. R2 is sending this information. R2 has sent a DVD packet to this guy. What R1 is going to do, R1 is going to request the same information. Hey, give me the detailed information. This is the short information. I need a detailed information. So that's why this guy, once the Ambuj is sending the DVD packet, short information, now the Amit is sending the LSR packet and he's saying that give me the number of Shruti. Now, what this guy is going to do, Ambuj is going to give the number of Shruti. Shruti associate with the 1, 2, 3. Now what Amit is going to do, Amit will maintain this information in the database. He said that, okay, Shruti is now associated with the 1, 2, 3. Now once this guy will receive this packet is known as a update packet, link state update. LSU packet that contains the detailed information. If you have look over now, if you go on this packet, so LSR was just a request packet. If you go to the link state update, detailed information. Can you see that? This is the detailed information. We'll discuss this in each and everything. Don't worry about that. I'm just showing you what is the meaning of detailed information and what is the meaning of short info. This is the short information. This is just a short information. Have a look. Just short information. This is the detailed information. Even the flag is also there in the router lesson. That we'll discuss each and everything. Forget this thing right now. I'm just making a clear understanding what is the meaning of detailed packet and the short packet. This is just a header information. This one just a header because it is a DVD packet. This is the LSU packet. Link state update packet. Update packet contains the detailed information. And then what happened once I'm going to store this information, then I will send a thank you so much. And this packet is known as the LSA acknowledge packet because OSPF is a reliable protocol. OSPF is a reliable protocol, and in the reliability, what happened whenever you are sending the update packet, I will give the acknowledge of that one. This mechanism, right, till this point, from here to here, from this point to this point, this state is known as a loading state. Once the database will be stored, right, once this database will be stored in my database, once the information, this information, whatever the information that Ambuj has given me as a Shruti number, right, once I'm going to store this information in the database, now what happened, now it will be the full state. It is something like that. Do you know, whenever you're downloading some file, from the YouTube, right, so for example, I'm downloading some books or movies, right, I'm downloading some movie. So what happened, for example, I'm going to download some movie like a Doom, right? So in this case, what happened? You will get a one folder of the Doom, right? And this file is a 2 GB. Try to understand what happened. Once I'm going to request to the YouTube server, the YouTube server will give the information on my desktop, right? But will I able to open this file right now? No, you cannot open it until or unless it's not complete downloaded. You cannot open this file because right now still I'm the receiving the information, right? Once the complete has downloaded, then you can open this file. So this is the loading process is happening. This is a loading process happening. Once the information is downloaded in the LSDB link state database table, right? The LSA information will be stored in the link state database. Once the all information will be stored in the LSDB, now I can open this packet. That is the meaning of full state. Once the downloading has completed, now they will move in the full state. So you will see this line in the loading state. What happened? I'm indexing my packet and then link state update packet. And for all this packet, we have a acknowledge. And once everything has cooled, then in this we will move in the full state. And the full state, what happened? The router has a fully adjacent with each other. And now the database has fully synchronized. Now if you see the neighbor, right? Now if you see the neighbor, show IP, OSPF neighbor, we see in a full state. Yeah, Prabhu, you are said that right. It was right. You first add the BDR, right? Then it trigger. Yeah, right. You are right. Guys, questions. Now we have done with the state. So we have 5 packets: hello packet, DVD packet, LSU packet, LSR packet, and LS acknowledge. You can see also LS acknowledge packet. So nothing is there in the acknowledge, just information about that LSA. That's it. Thank you so much.
Excuse me, sir.
Hmm.
Sir, what is that you told, sir? First BDR and DR, something you told me, sir.
The first BDR has been elected, then DR.
How much in both the places we have same router ID, sir?
No, first it is selecting the who is become a BDR, right? So it's going to say the BDR is 2.2. Now what above the router has been texting the router ID, he's saying that no, I have a higher router ID and you have a lower router ID. So you will become the DR and now I'm becoming the BDR. But the first it will go for the BDR.
Sir, and we'll get LSA request, no, sir?
Yeah.
LSA request packet will be sent here for the DBD packet.
Sorry.
LSR or link state request packet we are going to get for DBD packets.
In the DVD packet, what information I've sent that I have a number of Shruti, right?
Okay, okay.
So Amit is going to tell this, give me the information about the Shruti. That is the link state request. Miss, I'm asking the number of Shruti.
Okay. Okay. Okay, sir. Thank you.
Yeah, any questions? Parvo, clear?
Oh, yes, yes. Yeah, thank you.
Actually, on that time I get confused. Actually, I saw that this was the bug was that, so I need to check this because the sometimes what happens the Wireshark will give the wrong information. That's why I always believe in the CLI access code.
In normal scenario, it doesn't send the DR and BDR as the same interface, right? Normally.
Yeah, I know you cannot see that. Never.
Okay.
Now I'll see one thing that you do one thing. Let me make a different MTU, right? So I do on R1 interface 0/0 IP was to MTU will be not IP MTU will be 1400. IP was to process. Yes. Now they will stuck in the next start because of the different MTU. So how we can avoid this problem? So right now what happened? R1 is saying the MTU is 1400 because it's happened, right? Because if you have a different vendor of the devices, they have a different MTU, right? So in this case, what happened? You just need to go on this router R1 and see that interface 0/0 IP OSPF MTU ignore. Complete. So previously what happened? So because of the MTU, what happened? Neighbor 2.2.2 has a higher MTU. Because mine is 1400, you have a 1400, right? So R1 is saying that R2 is sending this packet to the R1 and start in the extra state. So if you have a MTU, this is also an important question for the interview, right? If you have a mismatch of the MTU, you will stuck in the extra state. So you can do one thing, just give the IP MTU. You know what's the meaning of that? Hey, I'm not going to look up for the MTU. Just give me the information. Okay. Questions? This is your OSPF states and the massive. Now we can start our LSA classes. That is the most important thing for the OSPF part. Anyone has questions, guys?